Chapter 7 Security and Protection 1. Introduction. Security and protection and security requires computer resources such as CPU, software's memory, SE. Are protected. This extends to the operating system as well as the data system. This can be done by ensuring integrity, confidentiality and availability in the operating system. Operating system security, O security, is the process of ensuring OS integrity, confidentiality and availability. OS security refers to specified steps or measures set to protect those from threats, viruses, worms, malware or remote hacker intrusions. There are various key differences between security and protection. OS. Some key differences between security and protection areas follows. Security is a technique used in operating systems to address threats from outside the system to maintain the system's proper functioning. On the other hand, protection is a technique used in operating systems to control hazards and maintain the system's proper functioning. The security technique specifies whether or not a specific user is allowed to access the system. In contrast, the protection technique outlines which users are permitted to access a certain resource. Security techniques include editing, deleting users, determining whether or not a certain user is authorized, employing anti-malware software, etc. On the other hand, protection includes techniques like modifying source protection information and determining whether user may access it. 2. Overview of system security. Security refers to providing a protection system to computer system resources such as CPU, memory, disk, software, programs and most importantly data/information stored in the computer system. If a computer program is run by an unauthorized user, then he/she may cause severe damage to a computer or data stored in it. So a computer system is be protected against unauthorized access, malicious access to system memory, viruses, worms, etc. We are going to discuss following topics in this chapter: authentication, one-time passwords, program threats, system threats, computer security classifications. 3. Authentication. Authentication refers to identifying each user of the system and associating the executing programs with those users. It is the responsibility of the operating system to create a protection system which ensures that user who is running a particular program is authentic. Operating systems general identifies/authenticates users using following 3 ways: username/password. User need to enter register username and password with operating system to log in into e-system. User card/key. User need to punch card in card slot or enter key generated by key generator, an option provided by operating system to log in into the system. User attribute. Fingerprint/eye retina pattern/signature. User need to pass his/her attribute via designated input device. Use it the operating system to log in into the system. 4. One-time passwords. One-time passwords provide additional security along with normal authentication. In one-time password system, a password is required every time user is to log in into the system. Once a one-time password is used, then it cannot be used again. One-time password is implemented in various ways. Random numbers. Users are provided card-shaving numbers printed along with corresponding alphabets. System asks for numbers corresponding to alphabets randomly chosen. Secret. User are provided the hardware device which can create a secreted mapped with user it. System asks for such secreted keys to be generated every memory or tologen. Network passwords. Some commercial applications send untime passwords to a unregistered mobile/email which is required to be entered pre or tologen. 5. Program threats. Operating systems processes anchor neldo that designated as instructed. If other program 8 these process do malicious tasks, then it is known as program threats. One of the common examples of program threat is a program installed in a computer which can store and send user credentials via network to some hacker. Following is the list of some well-known program threats. Trojan horse. Such program traps user login credentials and stores them to send to malicious user who can later on log into computer and can access system resources. Trapdoor. If a program is designed yet power has required heavy security wholly in a SCODI and perform illegal action without knowledge of user, then it is called to hobby a trapdoor. Logic bomb. Logic bomb is a situation when a program behaves only when certain conditions met, otherwise it works as a genuine program. It is harder to detect. Virus. Virus, as name suggests, can replicate themselves in computer system. They are highly dangerous and can modify/delete user files, crash systems. A virus is generally osmal codemedetana program. As accesses the program, the virus starts getting embedded in other files/programs and can make system unusable for user. 6. System threats. System threats refers to Microsoft system services and network connections. Stop user in trouble. System threats can be used to launch program threats in a complete network. Call it as program attack. System threats create such an environment that operating system resources/user files are remises. Following is the list of some well-known system threats. Worm is a process which can choke down a system performance using system resources to extreme levels. A worm process generates its multiple copies where each copy uses system resources prevents other processes to get required resources. Worms processes can event shut down a entire network. Port scanning. Port scanning is a mechanism where means by which a hacker can detect system vulnerabilities to make an attack in the system. Denial of service. Denial of service attacks normally prevent user to make legitimate use of these systems. For example, user may not be able to use internet if denial of service attacks browser's content settings. 7. Policy/mechanism separation. The separation of mechanism and policy is a design principle in computer science. It's the test hat mechanisms, those parts of a system implementation that control the authorization of operations and allocation of resources, should not dictate, or overly restrict, the policies according to which decisions are made about which operations to authorize and which resources to allocate. By separating the mechanisms and policies, we can make a more flexible system where modifications are easier to implement. This allows any system designer to develop mechanisms which will stay unchanged while it policies change to suit specific needs. Mechanisms and policies. An important principle is the separation of policy from mechanism. Mechanisms determine how to do something, policies determine what will be done. For example, the timer constructs a mechanism for ensuring CPU protection but deciding how long the timer is to be set for a particular user is a policy decision. The separation of policy and mechanism is important for flexibility. Policies are likely to change across places or over time. For instance, consider a mechanism for giving priority to certain types of programs over others. If the mechanism is properly separated from policy, it can be used to support a policy decision that I/O intensive programs should have priority over Q intensive and or to support the opposite policy. 8. Security methods and devices. What is OS security? The term operating system, OS, security refers to practices and measures that can ensure the confidentiality, integrity and availability, CIA, of operating systems. The goal of OS security is to protect those from various threats including malicious software such as worms, trojans and other viruses, misconfigurations and remote intrusions. OS security typically involves the implementation of control techniques that can protect the assets from unauthorized modification and deletion or theft. The most common techniques set to protect operating systems include the use of antivirus software and other endpoint protection measures, regular OS patch updates, a firewall for monitoring network traffic, and enforcement of security access through least privileges and user controls. 9. What are common OS security threats? Here are the most common threat vectors that can affect an operating system. Malware is short for malicious software which encompasses a range of vectors such as viruses, worms, trojans and rootkits. Malware is injected into a system without the owner's consent, or be masquerading as legitimate software, with the objective of stealing, destroying, or corrupting data, or compromising the device. Malware can also replicate, allowing it to spread further in a corporate network and beyond. Malware attacks often go detected, but the target is allowing for the quiet extraction of sensitive data. In other cases, attackers silently herd compromise a device into botnets and use them for criminal activity such as distributed denial of services, DDoS, attacks. 10. Denial of service attacks. A denial of service, DOS, attack is intended to clog a system with fake requests so it becomes overloaded, and eventually stop serving legitimate requests. Some DOS attacks, in addition to overwhelming a system's resources, can cause damage to the underlying infrastructure. Modern DOS attacks are used via distributed network of thousands or millions of bots, automated agents. This is known as distributed denial of service, DDoS, and can be extremely difficult to mitigate to a huge scale. An example of adus atticus therapy at the subsystem requests in a tidlook or a synflood in which the attacker sends a large number of network requests requiring the server technology icon and exhausting its resources. 11. Network intrusion occurs when an individual gains access to a system for improper use. There are several types of network intrusion depending on the type of intruder. Careless insiders authorize editors when neglect to follow security policies or best practices, causing exposure of sensitive assets. Malicious insiders authorize editors who misuse their privileges for malicious indigence. Masqueraders external individuals who pose as legitimate users exploiting the account or credentials of an authorized editor to gain access to a system. Clandestine users attackers who penetrate the system by gaining supervisory control and going around access controls. Buffer overflow. The main function of a buffer is to temporarily list data. Each buffer has a capacity of it can hold. During a buffer overflow attack, the buffer or other temporary data stores area overflowing with data. When the buffer overflows, the program attempting to write the data may overwrite other memory locations containing important information. Threat actors look for buffer overflow vulnerabilities which they can exploit. Inject scripts that help them eject the system or crash it. 12. How can you ensure operating system security? Here are a few ways you can improve operating system security on your organization. Authentication. Measuring authentication involves matching an identifier with the programs or data they are allowed to access. All operating systems have controls that can be used to verify that users were in a particular program are authorized to do so. You can use the following techniques to authenticate users at the operating system level. Security keys are provided by a generator usually in the form of a physical dongle. The user must insert the key into a slot in the machine intelligent. Username password combinations. The user enters a surname method is registered with OS along with a matching password. Biometric signatures. The user scans a physical attribute such as a fingerprint or retina to identify themselves. Multi-factor authentication. Modern authentication systems use multiple methods to identify user combining something the user knows, credentials, something they own, such as a mobile device, and / or a physical characteristic, biometrics. 13. Using one-time passwords. One-time passwords offer an additional layer of security when combined with standard authentication measures. Users must enter an equal password generate the activate log into the system. A time password cannot be used. Examples of on-time passwords include network passwords. An application sends a on-time password to the user's via registered email address or mobile phone number. The user must enter this password to log into the computer. Random numbers. The user receive as a card with listing numbers that correspond to matching letters. Those requires the user to enter the numbers that match a set of randomly generated letters. Secret keys. The user receive a device that generates secrets. The user then enters the secret key into the system which identifies the user credentials associated with the key. Virtualization. Virtualization enables to abstract software from hardware, effectively separating that. The main advantage of virtualization is that it introduces a high level of efficiency and flexibility while providing greater security coverage. There are many types of virtualizations including desktop application network, server network, storage and OS virtualization. 14. What is OS virtualization? OS virtualization enables to multiple select desire environments using the same OS kernel. The technology that creates and enables this type of isolation is called a hypervisor, which services a layer located between the device and the virtualized resources. The hypervisor manages the virtual machines, VM, running on the device, typically 2-3 VMs. Each VM is used for each user or each security zone. There are several types of VMs that can run alongside each other. Here are the three main categories. Fully locked down should be used to provide access to sensitive data and corporate systems, such as IT environments, payment systems, and sensitive customer data. Unlocked open VM should be used to provide unrestricted access to non-corporate resources. For example, full web browsing sessions, installation of applications, and use of external devices. Semi-lockdown should be used to provide access to standard corporate applications and resources such as office documents, company email, and internal services. 15. Advantages of OS virtualization. Each type of bemis limiteto the action salud design. Any further action is restricted. This keeps the environment secure. The hypervisor runs below those off the device and splits the device into multiple running locally with Thyronos effective isolating users. Because users are isolated, the devices remain secure. These ensures that employees and third parties can gain access to company resources without endangering company resources. Another major advantage of OS virtualization is that none of the virtualized environments can directly access the network. Instead, connectivity is enabled via an invisible virtualized network layer that implements network segmentation directly on the endpoint device. Testing and validating operating system security. Securing an operating system or a software is an ongoing process that requires constant testing. Depending on the risk on priority of a system security posture, tests may take place on a monthly, weekly, or daily basis. Here are a few testing methods you can use. 16. Protection, access, and authentication. Authentication mechanism determines the user's identity before revealing the sensitive information. It is very crucial for the system or interfaces where the user priority is to protect the confidential information. In the process, the user makes a provable claim about individual identity, his or her, or an entity identity. The credentials or claim could be username, password, fingerprint, etc. The authentication and non-repudiation kind of issues are handled in the application layer. The inefficient authentication mechanism could significantly affect the availability of the service. 17. Use of authentication in OS. Authentication is set by a server when the server needs to know exactly who is accessing their information or site. Authentication is used by a client when the client needs to know that the server is it claims to. In authentication, the user computer has to provides identity to the server or client. Usually authentication by server entails the surname and password. Other ways to authenticate can be through cards, retina scans, voice recognition, and fingerprints. Authentication by a client usually involves the server giving a certificate to the client in which a trusted third party such as VeriSign or Thought test that the server belongs to the entity, such as a bank, that the client expects it to. Authentication does not determine what tasks the individual can do or what files the individual can see. Authentication merely identifies and verifies what the person or system is. User attribute, fingerprint / eye retina pattern / signature. User need to pass his / her attribute of ID signet input device. Use it the operating system to login into the system. 18. Access control for an operating system determines how the operating system implements accesses to system resources by satisfying the security objectives of integrity, availability, and secrecy. Such a mechanism authorizes subjects, e.g. processes and users, to perform certain operations, e.g. read-write, on objects and resource software, e.g. file sockets. Example of authentication. For example, there is under sending an electronic document to the receiver over the internet. How to the system will identify that the sender has sent a message dedicated to the receiver. An intruder may intercept, modify, and replay the document in order trick or steal the information. This type of attack is called fabrication. 19. In the given situation, authentication mechanism ensures two things. First, it ensures that sender and receiver are righteous be blended, known as data origin authentication. Secondly, it ensures the security of the established connection between sender and receiver with the help of secret session key so that it could not be inferred, and it is known as peer entity authentication. Authentication refers to identifying each user of the system and associating executing programs with those users. It is the responsibility of the operating system to create a protection system which ensures that user who is running a particular program is authentic. Operating systems general identifies / authenticates users using following three ways: username / password. User need to enter registered username and password with operating system to login into the system. User card / key. User need to punch card in card slot or enter key generated by key generator, an option provided by operating system to login into the system. 20. Models of protection. Protection models represent the protected objects in a system. How users or subjects, their proxies in the computer system, may request access to them. How access decisions are made, and how the rules governing access decisions may be altered. The access matrix model is the primary example of a protection model. Access matrix is a security model of protection state in computer system. It is represented as a matrix. Access matrix is used to define the right so fetch process executing in the domain with respect to each object. The rows of matrix represent domains and columns represent objects. Each cell of matrix represents to access rights which are given to the processes of domain means each entry, ij, defines the set of operations the process executing in domain can invoke an object oj. 21. Memory protection. Memory protection is a way to manage access rights to specific memory regions. It is used by the majority of multitasking operating systems. The main goal of the memory protection appears to be banning of a process to access the part of memory which is not allocated to that process. Such bans improve reliability of the programs and operating systems, as an error in one program may not directly affect the memory of other applications. It is important to distinguish between the general principle of memory protection and ASLR and NX-bit. Memory protection is a technique of controlling and managing the functionality of random access memory, primary memory. It is used for achieving better concurrency system performances and memory utilization. Memory management moves processes from primary memory to secondary memory and vice versa. 22. In memory protection we have to protect the operating system from user processes and which can be using a location register with a limit register. Here their location register has the value of the smallest physical address, whereas the limit register has their geological addresses. These two register shape some conditions like ecological address must be less than the limit register. The memory management unit is used to translate the logical address with the value in the relocation register dynamically, after which the translated, or mapped, address is then sent to memory. In the above diagram, when the scheduler selects a process for the execution process, the dispatcher on the other hand is responsible for loading the relocation and limit registers with the correct values as part of context switch. A severe address generated by CPU is checked against these two registers and may protect the operating system programs and the data of the users from being altered by this running process. 23. Encryption. Encryption is a method of securing data by scrambling the bits so that computers file so that they become illegible. The unlimited of reading the encrypted files is by decrypting them with a key. The key is unlocked with a password. There are two forms of encryption. Symmetrical encryption encrypts and decrypts information using a single password. Asymmetrical encryption for encryption and decryption. Asymmetrized encryption is two keys. A public key which is interchanged between marathononi user. Data decrypted by a private key which is no text changed. The benefits of encryption include increased security and privacy, but disadvantages. The system requires detailed planning and maintenance. 24. Encryption is an important privacy tool when you are sending sensitive, confidential or personal information across the internet. Encryption scrambles plaintext into a type of secret code that attackers, cybercriminals and other online snooks can tread even if they intercept it before it reaches its intended recipients. The following figure shows what types of encryption. 25. Recovery management. Recovery management is the process of planning, testing and implementing the recovery procedures and standards required to restore service and even to a component failure, either by returning the component to normal operation, or taking alternative actions to restore service. Recovery management will assist in providing the necessary requirements to support day-to-day service delivery in the event of a disaster event. The recovery manager is the component that is responsible for processing commit and abort operations. It is also responsible for the restart operation which initiates recovery from a system failure. 26.